Welcome to the IPEtronic Online Academy. This video series will cover various topics in easy-to-follow-along videos. Additional assistance can be provided through the worldwide IPEtronic locations. IPEtronic is currently made up of 5 different business units. This video will focus on the Measure and Motion products. The topic of today's video is going to be the scaling calculator inside of the IPEmotion software. We'll go over some sensor scaling basics, the type of sensors and modules that are compatible, the scaling calculator itself, go over an example of a pressure transducer, and then look at the sensor database inside of IPEmotion. First off, let's take a look at some common analog sensors. The first type of sensor is an encoder that counts rotations. In this example, it's used in a flow meter. Every rotation generates one or multiple pulses that are then passed on to the data acquisition instrument. A strain gauge uses a Wheatstone bridge to detect a force that is being applied. The resulting change in electrical resistance allows us to calculate the force. A typical example for an IEPE or piezoelectric sensor is an accelerometer. It converts acceleration in one or multiple axes into an electrical signal. Pressure transducers are a common example for current or voltage-based sensors. Lots of models are also available as either current or voltage, depending on the type of setup. The pressure it measures deforms a membrane inside of the sensor. That membrane is equipped with another Wheatstone bridge. The signal is amplified and then passed on to the data acquisition system in the form of a voltage or a current. Last on our list, but probably the most common type of sensor, is a thermocouple. These sensors are made up of 2 dissimilar metals, and when the temperature changes, the change in voltage can be detected by the data acquisition system. There are different types of thermocouple sensors that use different materials depending on the temperature range that you're intending to measure in. Let's take a quick look at how all of this works in practice using a pressure transducer. The process is basically the same for all makes and manufacturers. In this case, we're using a Viatran sensor as an example. This transducer has a range of 100 to 30,000 psi and an output of either 0 to 5 volts or 4 to 20 milliamps. That voltage or current signal is then brought into one of our analog signal conditioning units, in this case the MSense24. The signal then gets converted into a digital message that we send to the data acquisition PC or the logger on CAN. The data acquisition system now knows how to interpret that message and turn it back into engineering units. Let's assume that the sensor is measuring 10,000 psi. If it outputs a voltage that results in 1.67 volts. Voltage is converted by our MSense24 unit into a CAN message. When the CAN message then arrives at the data acquisition system, the system decodes the message to read 10,000 psi. This process repeats itself depending on the sampling rate, but can happen thousands of times per second. Different signal conditioning modules are required depending on the type of sensor output. Our M-thermo line takes in different types of thermocouples. These are either designated for K or T type, or come as a universal module that can handle different types in one module. The MRTD can be used to handle resistance temperature detectors. All the products in our MSense line can handle current and voltage-based sensors. They are separated into low and high-speed modules. Our MCNT handles all types of encoder signals and frequencies. Our 6-channel MX-STG is the strain gauge module. It handles quarter and half bridge completion internally and has up to 100,000 samples per second on each channel. Finally, the MXSense24, which was previously mentioned as a voltage and current module, also brings in IEPE sensor data. To assist our users with sensor scaling, we recommend that you use the scaling calculator inside of the Signals tab. Find the Scaling tab for a selected channel and then launch the scaling calculator. We will go back to the datasheet of the sensor that we used in our previous example. The items marked in red are the critical components that we need to correctly scale our sensor. We need the full scale of the sensor, the supply voltage, and the output signal, in this case 0 to 5 volts. With this information, we can go back to the scaling calculator and insert the variables in the appropriate fields. We will select the output range of the sensor from the drop-down menu on the top right. After we've selected 0 to 5 volts there, we will input the total range of the sensor at the bottom left. We will also select the correct engineering unit from the drop-down menu or by typing it in manually. After we've confirmed our changes by clicking OK, we'll go to the Excitation tab and select the correct power supply voltage. The module will now supply the sensor with the power it needs to operate. If you do not require the help of the scaling calculator to scale your sensors, you can input the values directly in the signals overview. If your sensor requires excitation, don't forget to go to the Excitation tab and select the proper supply voltage. Let's take a look at this example, assuming that the sensor is not as straightforward to configure as the one in our previous example. It now operates between 1 and 4 volts and does 0 to 500 psi. In this case, we will scale by selecting the free 2-point scaling and finding a sensor range that is as close to what the sensor is as possible. Insert the output range and the physical range in the intended fields and click OK. Remember to set your excitation as shown before. We've now looked at basic configuration for pressure transducers. What happens if you're trying to bring in IPE signals or strain gauges? Let's start with the MX-STG and how to scale strain gauges. Select any of the MX-STG channels and find the scaling calculator. You will now find STG in the drop-down menu. Select the type of strain gauge you're using so the module knows what to do for bridge completion. Insert the other variables and click OK. The module will handle everything else. If your intention is to use an IPE-based sensor, select the MX-Sense24, click on any of the channels and find the Scaling tab. Since IPE is a standard sensor setup, this is already pre-configured in the drop-down menu. When you select IPE, there's no need for further adjustments or variables. If you choose to use any type of filters, please select them in the tabs as shown here. The final topic of our video is the sensor database. Find the sensor database button at the top right corner of the scaling calculator window. Some commonly used sensors are already pre-programmed when you install IPEmotion. Use the search and filter functions to find the sensor that you're looking for. When you find the sensor that you want to use, simply double-click and all of the settings will be transferred to the channel. If the sensor or sensors that you wish to use are not in this list, the list can be customized to include the sensors that you use on a daily basis. That way, you will no longer have to manually configure every sensor. Please reach out to us for further assistance if this is something that you wish to do. We hope that this tutorial has been helpful. If you have any further questions, please reach out to our info@IPetronic email address or your local IPetronic branch office.